Good morning, and this lecture is for principle of superposition 重ね合わせの定理 again for small signal equivalent accompanied with like this the voltage controlled voltage current source like this. And to make the basics of our knowledge to dealing with the electric circuit, analog electric circuit, or especially analog. This time, recently, on the topic of CMOS amplifiers noise, or thermal noise, especially. So we need effective equivalent representation of the actual circuit, and in doing that we need Thevenin equivalence or Thevenin Norton concepts, and the lemmas 1 and 2 presented in in a textbook written by a professor, you know, that at the time I mentioned source follower aiming its voltage gain expression of the voltage gain of source follower. The AC equivalent model is like this. At that time, this is source to bulk transconductance, and this is VBS, of course, and this is V out to AC ground of VDD, which is VDD. This is GMV sub 1. V sub 1 is from here to up here, which is derived V in input voltage. This is output voltage. We'd like to know V out to V in ratio as a voltage gain, a small signal voltage gain, and so we try to exclude this GMB register and included part to transfer to equivalent circuit. And in front sequence, in this sequence, we need to at first utilize First, both is okay. We need two steps. Firstly, find ZO, and next calculate BO to get to this. For this Thevenin equivalence. Finding ZO need to short V to ground, open all current sources applied, included open any, short all of the voltage source, open by all of the current source, and calculate and find, do some arithmetic action to find the O. This is easy. This is for sometimes difficult to reach good inspection. We need good expression to transfer from here to there. Good inspection with respect to this kind of voltage controlled current source included. Accompanied by this, it's tricky. For this, we need to utilize the thing I mentioned for the first time on this recording. That is principle of superposition. Superposition. I'd like to know the shared notation for this jargon. The time I first met of this word is on this book, The Principles of Quantum Mechanics, 4th edition by P.M. Dirac. This is famous introductory textbook written by Dirac. Dirac is won the Nobel Prize or not? Sorry, I don't remember. But Roger Penrose finally won the Nobel Prize this year. I'd like to congratulate him for his contribution to physical science, and to encourage the follower scientists, a lot of peoples, and he's just like a mathematician, but the Dirac's the formula introduced by Dirac is very is so vastly ubiquitous for scientists. It's and this book goes from the first chapter, from chapter 1. The title is The Principle of Superposition. So superposition here is single word. So I'd like to change this following him superposition, one word, position, and put the principle of superposition. Like quantum mechanics, we need this 重ね合わせの定理. In Japanese, 重ね合わせの定理. This is principle, not 定理. Principle. So just a little bit different. But I like this word because of this textbook. It starts with the need for quantum theory and what the principle of superposition. Chapter 1, all the chapter inference of energy, and it goes superposition and indeterminacy, superposition and indeterminacy. Summing up the importance element thought of quantum mechanics. Utilizing this, we first watching precisely what voltage and current source, what kind of voltage and current, and what numbers of all of these checked out, and I'd like to think expression in English, how to say apply when applying the principle of superposition to reduce the circuit to the Thevenin equivalent or simple components, and add up to final voltage, source, single voltage. I need English correctly and correctly understandable, correctly understood way. But this is one of the dummy trial, but I'd like to do this. And when applying the principle of superposition to some equivalent circuit to deduce to Thevenin equivalence, equates a more simple topology with just single voltage source and source register. We need to turn off each current source, short off each voltage source one by one. For this case, the expression is right. Shorten. Voltage source shorten each voltage source at the time to get a unit voltage source of each voltage source at a time. Shorten each voltage source. Each voltage source. Shorten no unit voltage. Get unit voltage source. So we need to remain just each one voltage source. So shorten every voltage source other than certain one mentioned. At a time, pick up more easily. We need to pick up one, select one voltage source. Source is excluding another, shorten every other voltage source. Every other voltage sources. Pick up one voltage source and short every other voltage source at a time. Circuit a certain one mentioned, which is this, to get unit voltage source, and open pickup after pickup one current source. Shortening opening every other current source at a time. To get unit current source. Pick up one voltage source, shortening every voltage sources at a time to get unit voltage source, and pick up one current source, opening every other current sources at a time to get unit current source. And add up to get one superposition voltage source or current source respectively. At this time we need to Thevenin voltage equivalent VO. Shorten V1. Pick up this V1. Pick up this V in, shorten V1. We find from here just VO equal one part of VO equal V in, and then shorten V in. Are there any voltage source remained? V1, well, it's tricky, but in a manner of AC common sense, AC sense B out is arbitrary open the circuit position and never moved in itself, and V in shortened with the V in shortening V in means the fluctuation of V in is disappear, and so this point voltage or this potential never change, and this is because this can be moved because of this. So this V1 is in a AC sense 0. So this shorted and this is 0, and so the GM-B1 equals 0. Current is at the same time opened. Current is opened. And looking at voltage, every current source is opened. So we need to mention GM-B1 if ever V1 is 0 or not, in this for deriving Thevenin voltage. So in AC meaning V1 equals 0, so VO equal V in, V sub O equal V sub O equals V sub in. So, and looking at the source of the M1 input N-channel MOS is 1 over GM of transconductance GM of N-MOS, that N-MOS is 1 over GM, so ZO equal find to short or open and short, and the open and short find 0. Open means DC connected, and looking at here, this is source and drain. There's 1 over GM of resistance, DC or AC 0. Short means AC 0 in small signal equivalent. So moving up and down the source voltage, we change VGS. So we find I equal VGM VGS. Now this is just VGS in AC sense. Okay, this is grounded, and this is input, and this is VGS moving. When looking at the resistance, and the resistance is VGS over I, which is 1 over GM. This is resistance looking at source of the MOSFET. When gate is AC grounded. When gate is AC grounded, and ZO equals 1 over GM. And we found this equivalence finally, just 1 over GM and one over GMB. Sorry, this is 1 over GMB. The V out is divided voltage of V in, and AV is this over this. And so I remember the principle of superposition from the book of quantum mechanics written by Dirac, P.M. Dirac. I read that in 1996 or 5. very fraction of the book I could understand, but the English is very beautiful, and I like the contents of the I remember the principle of superposition. There was a principle of superposition at the first time, at that time. So I utilized the principle of superposition in a sense for analog circuit, like AC, small signal equivalence to find out Thevenin voltage, and I feel comfortable to reading this book and go forward to next chapter. The elementary basics is the principle of superposition as Thevenin equivalent. To accelerate the derivation of the problem solution, what the matter, and divide the problem in a small part, and not calculating the tedious formula, make it more simple to concentrate on the solution to that problem. There's some method previously developed by earlier engaged peoples, researchers and engineers, mathematicians, scientists. So we utilize these concepts and method to accelerate ourselves to go to the target solution of the problem we get involved, we found. So this is one example of the acceleration. A very tiny example, but the probability of survival increase in 0.1% maybe. 0.1, probability 0.1, 10%, or this is percent or 10%. Not 10%. I mean this 0.1%. 0.1% too small. 0.1, 1%. Just this makes probability plus 1.1%, and these methods, all of these methods, in any case, applied in any case, you applicable. If you can apply, you will be applying these methods. You add plus 1%, maybe probability increase for your survival, and labor market using analog circuit, creating jobs. And then what this is small pickup of the previous recording concerning matter, but my understanding of that matter is this.